Hi guys, I am a machine learning engineer, and recently, when preparing for a machine learning system design interview, I found the resources on the internet very lacking, and there is no proper structure to the answers on the internet. So I could find few good pieces, something like Byte course, machine learning system design course, but none gave how you should structure your answer in like 30 to 45 minutes for a machine learning system design interview. So in order to uh, come up with a proper structure, I experimented and came up with a very good structure which helped me pass the interview. And hope this structure would help you too. That's why I'm making this video for video recommender system. Um, System design interview, design interview, uh, which would give you a proper idea how you should structure your answer and what you should tell in the span of 45 minutes, 35 to 45 minutes in a machine learning system design interview. And yes, this uh, YouTube channel I'm primarily keeping is for helping people pass machine learning system design interviews and share uh, my experience in a mission, how my machine learning um, interviews went and what tips and techniques helped me pass and what structure of uh, preparation helped me pass. I am starting with machine learning system design, by the way. Okay. The main objective is here to build a video recommendation system. I have few questions and assumption I like to get clarified before moving on to designing a video recommendation system. So the main business objective to build this video recommendation system is to increase the user engagement, right? Or should I also care about any secondary goals like maximizing the diversity uh, in the shown recommendations? Okay, I will only stick to user engagement. So uh, our the video recommendation system which we are developing shows uh, a personalized list of videos on the user homepage. Should it also show other kinds of recommendation like showing a recommended set of videos based on what the user is watching now, etc. Like next watch playlist, something like that. Okay, only stick to recommendations on homepage. Um, so since Meta is a global platform, I am assuming the users are across the world and videos are of different languages. Can I assume I have access to users' uh, interaction data with the platform, such as watch history, say, uh, like history, likes, uh, search history, and video impressions, etc. Great. Uh, so, how many videos are there on the platform, and how many active users are there on the platform? Million users. Mhm. And my final question would be how fast the system should be. I'm expecting the system should be very fast, uh, loading the recommendations on the home page, and the latency shouldn't be more than 200 milliseconds. Mhm. My So given this data, I would go about designing a video recommendation system uh, in the following structure. First, I would frame the problem as an ML task and give a high level overview of system. Second, I would go about data processing, which includes both data and feature engineering. And next, I would move on to modeling part and even training. Next, evaluation and deployment. and finally uh, consider any post deployment monitoring, etc. So we have the business objective of increasing the user engagement on a video service platform. Uh, the same business objective can be transformed into multiple well-defined ML objectives. So my ML objective for building this video recommendation system would be maximizing the the number of relevant videos shown. What do I mean by that? Uh, I have come up with a relevancy metric, which is a combination of both explicit user reaction and implicit user feedback, which is a video is termed as engaging for an user if he watches at least half of it or explicitly likes it. Mm, I went this with this type of uh, ML objective because solely going on explicit user feedback as likes results in very sparse data, although we have like a very clean signal. For example, a user might see hundreds of videos and may like one or two. And if you solely go with implicit feedback, like the user watch time on a particular video, it may also not be a good signal. Uh, but here at least we have like 100x. The training data would be 100x more, and would have like 100x more post to sample. So this would be my um, objective, ML objective. Now moving on to the high level overview of the system, let's build it. So we need to optimize for our video recommendation system for three things: latency, relevance or accuracy, and finally scale. Uh, a single machine learning model can only be optimized for at most two of the three metrics shown, and that's okay. In order to have a optimal recommender system that is optimized for all the three, latency, relevance, and scale, I would propose going with a multi-stage recommender system, and the recommender system architectures would be as below. So I would start with billion video vector store, billion video feature vector store, and which would be given as input to our candidate generation model. It is a very light sublinear uh, algorithm, sublinear complexity algorithm, which would generate thousands of candidates within hundreds of milliseconds. Uh, this candidate generation model is a recommendation algorithm optimized for optimized for speed and scale. I mean latency and scale. Uh, so it doesn't have the most accurate recommendation, but that's okay. We have like another recommendation model that takes in input the output of the candidate videos. This ranking I would call it as a ranking model, and this ranking model is optimized for uh, relevance mainly, apart from latency. And this would generate around, let's say, 200 candidate videos, uh, 200 recommendations, which would then go into business logic, which would be eliminating any region restricted videos or clickbait videos, etc. Uh, and we finally uh, give out the filtered videos coming out of the business logic and show it as recommended videos on user's homepage. Yes. Yeah, just this candidate generation model doesn't only take video features as input, it also takes user features which would be dynamically generated on the fly based on which user is querying. Sorry, uh, based on which user is querying. Uh, so I would quickly draw that and get back to the remaining things. So yeah, my overall high level architecture diagram of the video recommendation system I would be designing would be in this way. So we have two models, uh, uh, two recommended models, and it's a multi-stage design where one is optimized for uh, latency and doesn't care so much about efficiency. We call it as candidate generation model. The output of the candidate generation model would be thousands of candidate videos, which would be sent into a much higher complexity and highly accurate ranking model, which recommend filters out and ranks 200 recommended videos, which should be sent into custom business logic, such as eliminating erase and restricting videos or clickbait videos, and the filtered out videos would be shown on the home page, and this number would be around 100. Now let's move on to designing uh, the data processing pipeline. We'll talk about uh, the recommendation model architectures and algorithms in the modeling section. So in this data processing pipeline, we'll discuss both our data and feature engineering. Assuming I have access to the following raw data of users, videos, and user video interaction. I would assume the video we would have following video data: video ID, um, text, title, which is text, list of hashtags associated with it, tags associated with it, uh, and duration of the video, time of posting, language, mm, anything else. I think this would be language of the in which video is posted was there. The second thing is user. User would have user ID, age, gender, languages he speaks, and time zone, country, as well as city, and user video interaction. The user video interactions uh, can be stored in a table like this: user ID, video ID, uh, time of interaction, location of interaction, type of interaction, uh, amount of time it took for interaction. So given this data, let's see how we can generate useful feature embeddings for training our uh, video recommender systems. Um, so I'm organizing these currently. So in order to train a recommender system, we need to mainly have uh, two pieces of data. One would be a item embedding and another would be the user embedding. So given this video data, we can easily generate video embedding that encodes all the video features in the following way. Uh, so video ID can be encoded into an embedding using an embedding layer. Title can be passed through a pre-trained wet model and could be encoded, and the embedding could be generated. And finally, this list of hashtags can be also be sent through pre-trained wet model. Here we'll have multiple embeddings, and we can take an average of these embeddings to generate our hashtag embedding for the video. Duration can also be sent through an embedding layer, and embedding can be generated. As the same thing goes for time of posting and language. And once we always have this all these embeddings for the video, we can concatenate all these embeddings to have like a very informative video embedding or information rich video embedding, which we can use for training our machine learning recommendation models. I would go about how we learn this all these embeddings in the modeling session. In the same way we did for the videos, we can generate an user embedding. So I would just paste for the user embedding. As a result of all these features, without going into much detail. The next thing, the user embedding should also contain additional data such as user video interactions to give much more additional information about the user. But the user would have watched multiple videos. Generally, a single user would have watched multiple videos on the platform and searched for multiple videos and liked multiple videos and would have thousands of video impressions. To encode all of this into an user embedding, we would follow this strategy, averaging of embeddings. So what we do is, like, suppose we have watch history, we'll try pass it through an embedding layer, and for every video, watched video, we'll get an embedding, and we would average those embeddings and concatenate with the user embedding in order to convey this watched video history information. For all, we would do like this, and this would be concatenated with the user embedding. In this way, we form user and video embeddings uh, for training our video recommender system. We'll go about how these embedding layers are learned in the modeling session. Let's go about to the next step, which is modeling. Three main architectures are widely used for building recommender system. One is content based, another collaborative based, and the final one is two-tower neural network. Content based recommendation system mainly uses video features to recommend similar videos to the user based on the user's past video activity or like past watch history. Now, one of the main advantages of content based filtering is it doesn't have any cold start problem. Even just with user engaging in one video, we can find a lot of videos similar to what user has watched and recommend it to him. The main drawback is there would be less diversity in the videos recommended, as this content based filtering system only uses video features in order to recommend the videos. And coming to collaborative based filtering, it uses either user similarity or item similarity to come up with the recommendations. Uh, collaborative based filtering is based on the intuition that users with similar tastes will like similar videos. For example, let's say user has watched and liked a video A. I'm telling user A, and user A is very similar to user B. And if the user B hasn't watched the video A, collaborative based filtering will suggest that. So collaborative filtering is actually good for making diverse as well as engaging recommendations. But it suffers with a cold start problem, as the recommendations would be bad if there aren't enough user video interactions to find the users with similar tastes. The next would be two-tower neural network architecture. So When it comes to two-tower neural network architecture, it's like a combination hybrid recommendation system, which is a combination of both collaborative and content-based recommender system. Why would I say that? Since this two-tower neural network, as the name suggests, uses two separate encoders, or you can call it towers, to encode both user and item. Here it is video features. I would quickly draw the two-tower architecture. Um, User features, we give it as an input, and we get to the user encoder, and the output would be, we similarly have video encoder, um, video feature encoder, you can say, um, and features, video features, and the similarity would between these two would be found using dot product, and in order to train the model, we pass it through a binary cross entropy layer to get the output in between 0 and 1, and this prediction, now the recommendation uh, of a particular video to a user turns into a classification problem, where if the user likes the video, uh, we would label that as 1 and train our two-tower network to finally output 1 after doing dot product and binary cross entropy. What I am saying is, uh, this recommendation problem basically become a classification problem uh, at the core level. Yeah. So let's talk more about this data set creation. So uh, as discussed in the feature engineering session, we generate user embeddings and video embeddings uh, by concatenating all the different features. And user embeddings in Extra also have like user video or interactions too. Uh, so the final data set to train our machine learning model or two-tower architectures here is would be like this. We pick all the user video pairs to make a data set of user video pairs. Here the user video would be pairs would be an embeddings, user embeddings, and video embeddings, and uh, we also pick the ground truth label as whether user liked the video or not, based on the our relevance metric, which is a combination of implicit and explicit metrics. So even if the user have watched the video more than half or liked the video, we label it as 1, otherwise 0. Since we have, let's say, billions of videos and user would only have watched hundreds of, let's say, thousands of videos, uh, the number of negative examples are orders of magnitude higher than number of positive examples. So in order to create a data set, one way to mitigate the data imbalance is to only create the data set from the list of videos we have shown to user. If the user watched it or liked it, it is a positive example, otherwise negative. We still would have some data imbalance because if we suggest 10 videos, the user may watch only one video. To address this, we can use oversampling or undersampling techniques, etc. Sampling or undersampling techniques. And uh, the data set we have generated, uh, one note is like when we are generating user embedding, all the embeddings before getting concatenated can be scaled to 0 and 1, so as to have all the embeddings in the same range, which enables faster convergence, etc. And the next thing would be uh, the split of the data set should be time ordered, especially for this recommender system. Suppose we have like 1 year of data we can train on 11 months, first 11 months, and 1 month we can keep it for testing. Uh, Evaluation we can keep it for 2 weeks of data, and test subsequent 2 weeks. Now we should ensure the data should be time ordered, data set split should be time ordered. Otherwise, including uh, future videos, information about future videos, and predicting, including information, future information, and predicting the past uh, would be a sign of data leakage. And finally, the loss function for training this would be binary cross entropy loss. Uh, Loss between the ground truth label and the predicted label. And the see, here I am only showing the user features, but we will also back propagate the losses until the last embedding layer in order to fine tune the embeddings for this specific recommendation purpose too. Mhm. Now we have completed most of the modeling part. One comment I want to give is like both the candidate generation model and ranking model will use uh, same two-tower neural architectures, but the candidate generation, the size of the embeddings, each of this user feature embedding will be very small compared to the ranking model, uh, because we want the candidate generation model to be very lightweight and go through billions of video feature vectors in a short amount of time. Um, um, yeah, and the ranking model would be a somewhat complex two-tower architecture uh, with its own set of embeddings, which could be much larger compared to the candidate generation model. Now let's go to the evaluation metrics. So uh, in order to evaluate our model, we have recommendation system. We have two models. One is candidate generation model. For this, we can use recall at the rate of k, since at this stage we are only interested in seeing how many relevant and recommended videos our candidate generation has picked out of the existing set of relevant k videos it has picked uh, out of all the relevant videos. Uh, Even if the recall is low, it's okay, since we have another model which is ranking model. Here the main evaluation metrics for this model should be precision at the rate of k. We can also rank the recommendations predicted by our ranking model by just ordering in terms of the output of the logistic regression layer, sigmoid layer of our neural net. So if we are still cared about ordering too, which we should, in this particular video recommendation system, we can go for average precision at the rate of k, or NDGC, which is normal discounted cumulative gain, uh, as we should also care about the ranking of the recommendation. And for the online metrics, we can use the same thing we have described at the start, which is maximizing the number of relevant videos shown. And let's say we deploy a model, and after a certain amount of time, we record the user interactions with the recommended videos to the user and see uh, calculate the relevancy metric. If the relevancy metric is high, we can roll out this model to all the users. Otherwise, we need to see where it went wrong and come up with uh, better features or debug the entire pipeline in order to get better online metrics compared to the previous model. And finally, let's talk about deployment. So we do batched offline prediction of all our video encodings. And store it in our uh, a video feature store or a video feature database. We do this because we have billions of video feature vector, billions of videos, and combing through all of them for a particular user would be infeasible. Uh, and the user features will be calculated on the fly uh, whenever the user logs into his homepage or refreshes the homepage. And yeah, for the candidate generation model, uh, we use the two-tower architecture, uh, but the way for training, but for the way during the inference, what we do is, like, given a user embedding, we'll find the 1,000 most closest videos relevant to the user using approximate nearest neighbor algorithm. Since we use this algorithm because it's a sublinear complexity and it can go through billions of video feature vectors in less than in less than 100 milliseconds. And for the ranking model, uh, we get the output of the binary sigmoid layer, and this output, whatever the value, is used to rank the video and then recommend it to the user. In this way, we go about deployment, and yeah, the video features are calculated offline as a batch prediction. And finally, we mhm, uh, the post coming to post deployment monitoring. Two things we can talk about is cold start problem and periodic retraining. Uh, this the recommendation model can be retrained once in, let's say, a month, or more frequently, let's say, a week, in order to stay relevant with the changing trends, etc., and not make the model stagnant, etc. And for the cold start problem, we can use heuristic features, either when we have a new user, and collect user interactions and video interactions with the user to fine tune our neural network to make better recommendation. This would be my system design for video recommendation system. Thank you.